this is just a review. So you could try all three methods on your own to see if you remember them. And the answer should be the same, 2/5 and -3, no matter which one you choose.
What page?
340. So if you want to get that down later, you can. We're going to skip the construct the understanding. And this unit, we're looking at, instead of quadratic inequations, we're looking at quadratic inequalities. So I'd like you to do is on page 341, you have room on the side. I'd like you to write down these instructions or these steps for solving a quadratic inequality. We solve them almost identical to solving quadratic equations. We're going to make one side equal to 0. And once we've got it equal to 0, we're going to solve it just like we did in chapter 3. So that's number 2. It says pretend equal to 0 and solve. Then the new stuff comes in step number 3 and 4. And we'll see why we need to do this to figure things out. But I'll let you write down that first. Chapter 4, you graph things like y equals x squared minus 2x minus 3. Maybe you did this in factored form and found x-intercepts at -1 and 3, and then found your vertex at 1, -4, or maybe you completed the square. What we're going to do in this unit is solve questions like chapter 3, except instead of an equals to 0, it's greater than 0. So what I want you to do right now is we're going to look at this. X squared minus 2x minus 3 greater than 0. And I'm going to make a little chart here. And I want you to tell me an x value. I think an easy one would be 0. If x is 0, is it true or is it false, the following statement?
False.
If x is 0, it is false. So I can put 0 is definitely false. Can you tell me a number that works? That you plug it in and it makes it true. 1. So I do 1. Minus 2 be -1, -3, no. That'll be a -4, right? So I can put that here with the false one. That's the nice thing about this chart. You try a value, and it's going to work or not work, but you're going to be right as long as you put it in the right column.
-2.
-2. If I try -2, this would be 4 plus another 4 minus 3 would be 5, right? So x equals -2 is true. And it's going to be our job to find every single number that's true. There's more than just one. Can you find another number that's true?
-3.
-3. Good.
-4.
-4. Okay.
-5.
-5.
-6 and 7.
negative 6.7, and negative 6, and negative 7.
Negative 48.
Negative 48 works. There's a lot that work, right? How do we find out all of them that work? All the negatives? What? Do all the negatives work? No, because I can put in negative 0.5 and it doesn't work. Can somebody find a positive number that works?
No.
Hmm?
No. Doesn't work.
No, doesn't work. Like if I plug in 10, 100 minus 20 is 80, minus 3 is 77. 77 is definitely not bigger than 0.
Yeah.
Oh, wait a minute. Sorry. I think 77 is bigger than 0. So 10 works. Now, we want to find all the ways that work. And what we wrote in our steps here is we make one side equal to 0. It was already equal to 0. Now we're going to pretend it is 0. So if you pretended it was equal to 0, what would you get? You could factor this one to solve. I would probably use that rather than the quadratic formula because this is an easy one to factor. And we find out at minus 1 and at 3, it's equal to 0. So would minus 1 and 3 make this true? No. Minus 1 and positive 3 wouldn't work. But they're the places, and we can see it on the graph here, they're the places where your graph is equal to 0. Notice all of these negative numbers that we put in? Your graph is, y values are positive. Anything bigger than 3, if you tried 4, 16 minus 8 is 8 minus 3 is 5. It works. So what we're going to do in the steps here, it says, once you have solved it, make a number line with your solutions. So here's my number line, here's my solutions, minus 1 and 3. And we're going to find out that we're going to use open circles when it's a less than or greater than sign. And we're going to fill in those circles if it includes the equal sign. We put open circles to remind us that minus 1 and 3 are on the false side. But then in this section here is always true. This section in the middle, all of those y values would be negative. So anything you plug in for x in that section would be negative, that section would be false, and this section will be true. Then we're going to write our solution either like this, in interval notation, goes from negative infinity to negative 1, and then again from 3 to infinity. And when we have two intervals, we put a u in between. Or we can write this as x values we solve for. X is less than negative 1, or x is bigger than 3. You get to choose which form you like to write the solution, in interval notation or in set notation. So one way of figuring this out, and they've got it here in your notes as well, is they say from the parabola you can visualize if this was equal to y, then you would get the graph. And we're looking for where the y values, because this is y, where are the y values bigger than 0 on your graph? So wherever the parabola is above the x-axis, that will be the true statement. If we had this same question and it said less than 0, then the answer would be between negative 1 and 3. So I'd like you to highlight this. We call the x-intercepts of the graph are the critical values of the quadratic inequality. Like, I feel like, make up your mind. They've got like, sometimes they say x-intercepts, sometimes they say zeros, sometimes they've said roots, Sometimes they've said solutions, and now for inequalities we're going to create a new word, critical values. All of these things mean the same. Off to the side, what I mentioned in that example is that when it's a less than or greater than sign, we're going to draw our number line with open circles, and we're going to put closed circles and so for this one, the middle section would be true and the outside sections would be false. And we'll often write true and false over the sections. And there's a couple of different ways you can find out if it's true or false. If you plug in one value, like I plug in 0, that's between -1 and 3, into the equation. -3 is less than 0. If you plug in one value and that value is true, that means that whole section is going to be true. So if I plug in 4 right now, 16 minus 8 minus 3 is 5. That is not less than 0. One value in this section false means that whole section will be false. So you can find out where it's true and false by plugging in values. You can also see where it's true and false from the graph. If you drew a graph and you had 2x-intercept and this parabola opens up, when you draw the graph, this graph is y equals x squared minus 2x minus 3. So we are looking for where are the y values, because this is what the y values equal. Where are they less than 0? That's in that section there. So you can also figure out false, true, false very quickly from a graph. So we need to know chapter 3 and chapter 4 for doing chapter 5. The only thing for chapter 5 is we're adding these inequalities. Okay, let's go to example 1 and work through the steps. So, when solving a quadratic inequality, first of all, we make one side equal to 0. Temporarily, make it actually equal to 0 and solve. And usually in this unit you can solve by factoring. So if I could factor this, this would have to be 3x and x. This would have to be 1 and 1. I need my outside and inside to make plus 2, so I'd go outside plus 3, inside minus 1. Double check, multiply it all out, it works. So then I get x equals 1/3 and x equals -1 as possibilities. I then create a number line. Now I can go back. I temporarily wanted to find out that, and on my number line, -1 would be here, 1/3 here. It doesn't matter where I space them. And will I use open circles or closed circles on this one? Open circles, because I have just the less than sign, so I want to remind myself that these values are not included. If I plug in -1, it makes it equal 0, so it is false at -1. If I plug in 1/3, it would equal 0, so it's false at 1/3. Now I have to figure out whether this is going to be false, true, false, or true, false, true. What is it going to be for this one? Two ways you can go about this. You can do test points. So if I try 0, what happens when I plug in 0?
Little line or something.
Again, -1. True or false? Is -1 less than 0?
True.
True. So because I tested a point in between here and it's true, this section, all of it will be true. Similarly, I could plug in -2. This will be 12 minus 4 minus 1 will be 7. Is 7 less than 0? False. I would find out this whole section is false.
Go down, finish the math contest, you're still writing.
Okay.
This is a checklist you can give the kids for
All
the
right,
test.
did you want her to just bring her in here?
She's coming, yeah.
Okay. And similarly, if you did a test point here, you'd find it's false. You can also use chapter 4. By factoring it, you found the x-intercepts. We know that there's an x-intercept at -1, and there's an x-intercept at 1/3. Which way would this parabola open, up or down? The a value is a 3. It opens up, so this is your parabola. Can you see that if you want less than 0, it is only true in the middle section? So once we've done our number line, and we labeled what's true and false, I'll just write the solution and then I'll get your question. We can write our solution, and you can either write your solution in interval notation. So here, the true part goes from -1 to 1/3. We have round brackets because the -1 and the 1/3 are not included. Or you could write it in set notation, which says the x value is in between -1 and 1/3. Question?
Are the outer sections always the same? So like
Yes, with a parabola. Once you get into calculus and you have to do this with increasing and decreasing functions, no. But for parabolas, because the way a parabola works, it'll always be either false, true, false, or true, false, true.
Yeah, so right now I only have to plug the outer points in if I want to test it.
Right.
But
I could give you a question. I could give
for
you,
the points where it
yeah.
isn't false.
If you have two x-intercepts, that's the case. I could give you a question like this. There's my parabola. And
No x-intercept.
no x-intercepts.
Mhm.
And if it said, when is the parabola bigger than 0, it would be always true. I could give you a parabola that looks like this,
Only for 1 point.
right? So I'll actually write let's say this is negative, whoops, brackets the wrong spot. Negative, let's say that's 2. X minus 2 squared. And if I asked you, when is you would have a number line with just 1 point. And this section would be true, and this section would be true.
Yeah.
So your answer would be from -infinity to 2. This one you can write that way.
Mhm.
Everything except x can't equal 2. Everything else worked. So there are some exceptions, but for the most part, if you have two x-intercepts, the outside ones will always be either both true or both false. That is a good pattern to recognize. Okay, questions you can circle for number 1 are 4, 5, and 6.